All right, so this is section 9.3, and we're going to learn about graphing inequalities. There's some special information you need to know. So when you graph a line with when you graph an inequality line, if you have this less than or equals or this greater than or equals, it needs to be a solid line. But if you just have less than or greater than, it needs to be a dashed line. So on the example below, this is solid and this is dashed. Okay, and tell me this on the test. Don't just skip it. This first equation, my m is equal to 1 and my b is equal to 3. And the second equation, my m is equal to -1/1 and b is equal to 5. Okay, so all the rules of graphing hold true that we have learned thus far. We're just going to have some additional information we have to do. All right, so here we're going to go. We're going to go up to 3, 1, 2, 3, and we're going to go over 1, up 1, connect those points with a solid line. Now the second one, I'm going to go up to 5, and I'm going to go down 1 over 1. And those are, oh, well, that didn't work. Those are connected by a dashed line. Okay. Now, not only do you have to graph these, but then you need to shade. Every inequality you need to shade. So I'm going to look at that first equation, x plus 3, and I'm going to test the point to determine which way to shade. I'm going to test the point 0, 0. I can test the point 0, 0 right here because that line, this line here, is not on that point. I can test any point so long as the line doesn't go on it. So I'm going to throw in 0. Is that greater than or equal to 0 plus 3? And that is false. Okay, when it's false, I look at the point 0, 0. It is on the bottom half of that line, so I have to go to the top half of this line in order to start my shading. Now I'm going to test on my second equation. I'm going to also test 0, 0. Here I go. Is 0 greater than 5 minus 0? No, that's false too. Okay, so I'm going to come here. I'm going to go to 0, 0 and look at 0, 0. And I see that it's false, so I need to go to the other side of the dashed line. And I'm going to go like this. Okay, and that area, this area up here, is my solution set. Okay, this is where they overlap, and that's your solution set. And you will use that on Math Excel. So what about another example? Well, this example is that's dashed, and this guy is dashed too. So my m is -4/1, and b is equal to 3. M on this problem is 1/1, and b is equal to 4. All right, so the first one I go to -3, 1, 2, 3, and I go down for 1, 2, 3, 4, and over 1. And I've got dashed lines. Sorry, my dashes don't work too well. And then on the second one, I go up to 4. And then I go over 1, up 1. And that again is dashed as well. But again, I need to test a point on each one to see which way to shade. So I'm going to test on this first one, 0, 0. Can I test 0, 0? The answer is yes. My first line does not go through the point 0, 0. So I'm going to plug it into the equation. Is 0 less than 0 minus 3? So is 0 less than -3? False. All right, so I'm going to come here and look at this. Oh, so 0, 0 is here. My line is here. So I need to go to the other side of the line. If it's true, I stay on that side of the line. And the next one, I want to test 0, 0. 0, 0 is a really easy test point. You're just going to come across particular examples that you cannot test it. Is 0 greater than 0 plus 4? So no, that one's false as well. All right, so come here and look at 0, 0. My line is here, so I have to go to the other side of the line. And so that area where there's this double hashing, that is your solution set, and that is what you would use to shade with in Math Excel. Let's look at this example. How might I graph this? Well, just like any other time, this isn't set up directly as an YX in intercept slope form. So I might do an XY table. So for the first equation, I'm going to pick Y values. I'm going to pick 1. I'm going to throw it in there. So X is equal to 5 times 1, which means it's 5. And you're going to use an equal sign rather than an inequality to find the actual value. In the next one, I'm going to use 0. So I'm going to have 5 times 0. So X is equal to 0. So I got 2 points for that one. The second one is in intercept form, where the X and Y are on the same side. So that means I can pick 0 for X and 0 for Y. So the first one, 2Y is equal to 8. Divide by 2, divide by 2. Y is equal to 4. And then the second one, I have X is equal to 8 when I plug in 0 for Y. So that gives me my points. All right, so the first one, I have the point 5, 1, 2, 3, 4, 5, 1, and the point 0, 0. This one is solid, and this is a solid line too. So I come through and I make my solid line. The second one, let's do 0, 4, 2, 4, and 8, 0, 2, 4, 6, 8. Okay, now let's pick a point to test. I want to test. I've always wanted to test 0, 0. But this particular line, this first line, it goes through the point 0, 0. So I cannot test 0, 0. I can, however, test the point, say, 0, 1. Okay, here's 0, 1 right up there. So let's put that in. So is 0 greater than or equal to 5 times 1? And that is false. All right, so here's my 0, 1. So there's my line, so that means I have to go to the other side of the line. Now let's test on the second one. Let's test 0, 0, because that line does not go through it. So is 0 plus 0 less than or equal to 8? So is 0 less than or equal to 8? That's true. Okay, because that's true, and my thing's not going to, I can come here, look at my 0, 0, and shade on that side of the line. So here, where they double hatch, is my solution.